Hello, my beautiful Mishler Math students. Welcome back, and let's talk about direct variation. D-I-R-E-C-T, direct variation. Now, I may do this from time to time, but I'm going to switch over to our textbook. Let's take a look at the textbook. And direct variation and proportion. Why? Here's a good question right here. Why? Many events in the real world have a direct variation relationship. For example, the distance you travel when bicycling can have a direct variation relationship with time. Well, with your bicycling or driving or walking, it's a direct variation equation. So our objectives in this section, we want to write and apply direct variation equations. We want to write and solve proportions. So those are the two things we're after, okay? So it says each day Jonathan rides his bicycle for exercise. When traveling at a constant rate, he rides 4 miles in about 20 minutes. At this rate, how long would it take Jonathan to travel 7 miles? To answer this question, use a direct variation equation. Okay? And we'll talk about that in just a moment. But first I want to take a look at the direct variation on a graph. Now, I want to tell you something really exciting here, because this is something that's going to be so simple to you, okay? And first of all, a direct variation equation is the simplest linear equation you can find. And it looks like this. Y equals kx. Okay? Very simple. The k is your constant of variation. Now, constant of variation, that can't be 0. If y equals 0x, then of course you just have y equals a number, and you won't have anything there. So I'm going to show you what I'm talking about here. Let's draw a line first of all. And let's make this real simple and straightforward. If I start here and I draw a line through the x, or through the origin, like that, okay? What I have drawn here is a constant variation equation, or the graph of a constant variation equation. Now, it starts at, what's my y-intercept? The y-intercept is 0, isn't it? So if I say y equals mx plus b, well, the b is going to be 0. And so I don't have to worry about that. In other words, now all I'm worried about is y equals mx. Doesn't that look a lot like y equals kx? That's because that's exactly what it is. We call the m, in this case, we call it k, the constant of variation. So how do we find the constant of variation? Well, let's find a point right here. Okay, that's a point here that 1, 2, 3, 4, 5, 6, 7. 7 on the x-axis. And 1, 2, 3, 4, 5 on the y-axis. So I've got an ordered pair, 7 and 5. How do I find the constant of variation? Well, let's see. When x equals 7, let me change color here so we can see it clearly. When x equals 7, y equals 5. So 5 is going to equal k times 7, isn't it? Watch, this is going to blow your mind. Divide both sides by 7, and this is what we have. K is 5/7. So k, and look at, this is 5 is what? 5 is your y. 7 is your x. So k is real simple. It's y over x. How do you find slope, ladies and gentlemen? M is the change in y over change in x, isn't it? How do you find the constant of variation? Let's do a little algebra here now. If y equals kx, let's do this down here. Y equals kx. If I divide both sides by x, what do I have? k equals y over x, right? So if you want to find k, you just take this y and put it on top of x, and that gives you your k. You say, well, which point do I use? I can use any point I want to on this coordinate plane. Okay, any point that the line passes through. I take the x and the y, I put the y on top, the x on the bottom, and that's going to give me my constant k, the constant of variation. Say, well, okay, this is all a little bit confusing. So let's try something. Let's try an example. Okay, so an example looks like this. Okay, all right. If that's it. If, okay, if y varies directly, oh dear, bad handwriting. I hope you'll forgive me for the bad handwriting. If y varies directly as x, this is an important statement. You're going to see this from time to time. Y varies directly as x. That means we have a direct variation equation, okay? Then find k when y equals 15 and x equals 3. So, all right, let's make it easy here. Y equals 15, because remember, y equals kx. So y equals 15 when x equals 3. So 15 equals k times 3. Well, first of all, I don't even need to worry about my equation. I just look at this. I've got a y and I got an x. 15 over 3 equals 5, doesn't it? Remember, I said k is equal to y over x. Remember that up here? I said k is equal, right here, k is equal to y over x. Because I got rid of the x over x. Okay, k is equal to y over x. So k equals y over x. 15 over 3 is 5. So, say, well, okay, I like doing it this way. Y equals kx. So 15 is y equals k times 3, which is x. Divide by 3. Divide by 3. You see that? It's pretty much what I just did, isn't it? K equals 15 over 3, which equals 5. So any way you look at it, it says find k, k equals 5. Now the next thing, rewrite the direct variation equation using this k that we just found, using k equals 5. So I'm going to rewrite the direct variation equation. Instead of writing y equals kx, I'm going to substitute 5 for this, okay? So I've got y equals 5x. That's my direct variation equation, okay? So use this equation now. Let's say I want to use this equation. I'm running out of black space here. So let's say I want to use this equation to find y when x equals 14. Okay? Well, that's pretty simple, isn't it? Y equals 5 times x equals 14. So 14. What's 5 times 14? No, equals 70. So when x equals 14, y equals 70. Okay, a couple other things we want to find out, and I'm going to clear this whole thing out. And you remember the bicycle thing we talked about a few moments ago? Remember that, the bicycle thing there? Well, first of all, now I'm going to point to the book, a couple things in the book. It says direct variation. You see this is blue right here. I call that a blue rule. Direct variation, the variable y varies directly as x if there is a non-zero constant k, remember I said k cannot be 0, such that y equals kx. The equation y equals kx is called a direct variation equation. The number k is called the constant of variation, okay? So find the constant of variation k when the direct variation equation, if y varies directly. Well, I just did that. Okay, I just did that one for you. All right. So here we're talking about the bicycle equation. This is example 2, and so let's take a look at that. And in this case, remember I said that the bicyclist goes 4 miles in 20 minutes. Okay. Well, we're going to use the here we go. Okay, 4 miles in 20 minutes. And the direct variation equation that they use is distance equals rate times time. Now all we're doing is we're saying y equals k times x, but we're just changing the letters around. X is time, y is distance, k is your rate. That's your speed. Okay? So the distance that he travels is 4 miles. So 4 equals the rate times 20 minutes. It takes him 20 minutes to travel 4 miles. So we divide by 20, divide by 20. R equals 4 over 20, which equals 1 over 5. So now I can rewrite this equation, forget that, rewrite this equation as distance equals 1/5 times the time. So now I want to know how long does it take him to drive 7 miles. So let's put a 7 in here, and let's change colors because we've been using green long enough. 7 equals 1/5 times time. How do I solve this equation? I multiply both sides by 5. Okay? Why would I do that? Well, because 1/5 times 5 equals 1, and I want 1 times t over here. So 5 times 7 is 35. 1/5 of t times 5 is equal to t, or 1 times t, which is t. So the time to travel 7 miles is 35 minutes. It takes him 35 minutes to travel 7 miles at the rate he has been going. Now that's a real world situation where you're using algebra to solve a real world problem. A couple more things here I want to show you, point out to you here. And look at what I found there. Okay, let's get edit clear. And one more thing, a couple more things I want to show you. And that is, what is a proportion? Does anybody remember what a proportion is? A proportion is A over B equals C over D. A proportion is nothing but 2 fractions equal to each other. That's what a proportion is. You just take 2 fractions and make them equal to each other. Okay? So, and you know how to solve a proportion, don't you? You cross multiply. Because if A over B equals C over D, then A times D equals B times C. Now there's a trick here, and that is that B, D cannot equal 0. We can't have either one of these be 0 because division by 0 is undefined, etc., etc., etc. So we can't have them be 0. But what we can do is we can solve equation proportions with this formula. Okay, so we got let's suppose we have 3x plus 2 over 7 equals x over 2. So we need to solve that proportion. Okay, solve means find out what the value of x is. Okay, so let's see what the value of x is. I'm going to cross multiply. Okay, 2 times 3x plus 2, or if you prefer 3x plus 2 times 2, either way, that's what that is, equals 7 times x. 2 times 3x is 6x, plus 2 times 2. Do not forget to use the distributive property. 2 times 2 is 4, and that equals 7x. And if I subtract 6x from both sides, I get 4 equals 7x minus 6x, which is x. And I'm sorry, that's a little, x equals 4. Now, one thing I always insist on showing students, take a moment when you solve an equation, put that x into the original equation, and make sure it works. For example, what's 4 over 2? Equals 2, right? What's 3 times 4 is 12. 12 plus 2 is 14 over 7, and that equals 2, okay? So 2 is equal to 2, so we have a true statement there. If I make x equal to 4, this thing works. So that's it. That's how you solve a proportion. Pretty sure that will give you enough information to do the assignment that I'm going to give you in class tomorrow. You need any further information, I will certainly help you with that. Thanks.